Alright, so I'm back. Excuse me. And I was wanting to show you a couple things here, particularly on this book. So there's a difference between what we do for welder qualification versus procedure qualification. I'm going to set it here. I'm going to zoom in a little bit on this. And try to make sense of this at this point. So here's a good example. Here's a 12-inch pipe. This is the API code right here. Okay? Look at all those coupons you have to cut out. There's 16 of them. Up here we've got, so here's a good example. Any of you that have tried to do, or have done a 6-inch pipe with me, you know that you have to take, number one, for performance, we're taking a face, root, and root. Now look what it is for the procedure. The procedure tells us that we have to take a face or a side bend, depending on wall thickness, a root, and then over here's the face and the root together. So this is a tensile piece, this is a nick break test, tensile and a nick break. So this is API 1104. 1104 is the only one that has a nick break in it, okay? But look at that, 8 coupons instead of 4. And these 4 are just for mechanical testing to make sure that this stuff is actually applicable and it can, the weld that we just did is metallurgically capable of holding together. Okay, that's basically the part for the PQR, or the welding, or the procedure qualification record. It's quite simply this. The procedure shows that the mechanical abilities of this equipment is fine. So if I join 7018 and A36 steel, it matches the mechanical properties, the tensile, the yield, the elongation, the ductility, everything falls within that spec. That's the PQR, right? So we welded it, now we've went in there, now we've tested it, and all of our test coupons, our tensils, our nick breaks, our reduced section tensils, have all fell within the spec that we need. So that means that yes, it's proven, everything is there. Now we can create the procedure specification out of it. So now what we did is we just proved our guidelines, right? So we just made our own rules. It works, it's mechanically sound, we're good. Okay, so we just developed the welding procedure specification, which is the rules and guidelines. And the way we wrote that is, number one, we had to prove that it was mechanically fit. Now we haven't talked about the welder's skill or anything yet. That's the mechanical piece, the PQR, was what told us that it was a good weld, it fell all within code spec. We didn't even talk about slag or anything else. We said the metallurgy alone is fine. Now we go into the next round. Okay, so we've got guidelines, we've got the mechanical ability proven, so now we're going into the performance qualification. So we've got the WPS, the welding performance specification, the PQR, the procedure qualification record, which we talk about here in a second. There's 3 different ones. And now we're going to go to the WPQR, which is the welder performance qualification record. And that basically is saying that they can weld that exact weld to the correct codes and limits. Okay, so here's the deal. If they were the welder that helped develop the PQR, they're automatically qualified. Okay, because it fell in spec, everything was there, they don't have to retest for it. But they also just developed a procedure, so when a company says, hey, I want to do this, and it might be the same thing that everybody else has done, but they have to develop it and they have to call it Chris Boffman's Welding Company Procedure. Okay, I can't use, you know, somebody else's welding procedure, Dan Aykroyd's machine shop welding procedure, because he paid for that. That's his procedure. I have to develop my own, which may cost me $3,000 to $4,000 to develop my own, right? Now, that's where the next part of this is going to go into. You know the difference between WPS, PQR, and WPQR now. But there's this thing called pre-qualified procedures, and really the only ones that are there, for the most part, are the AWSs, and particularly D11, okay? The pre-qualified procedures, which we've talked about, it means that you don't have to reprove them. As long as they stay within the certain guidelines that are there, that are set out in the code of 8 inch 7018, it's got to be this weld joint, this spec, the tolerance is here. As long as they're within that procedure, you're good. You don't have to pay the extra $3,000 to develop them. What you do have to do is you have to write in your company procedure and submit to your insurance company that you're going to use that pre-qualified procedure as your own. And you as the fabricator or contractor is still responsible for qualifying your welders to that procedure. It doesn't mean that they're all qualified to weld in that way, okay? Now, so I just described the difference between these two things. The first one is pre-qualified, it's already been tested, but the second one, the procedure testing, that's what I developed, that's what I walked through when we talked about the actual pieces that we had to test and everything else. That's what we did there. Now, that's assuming that it's a regular butt joint, a T-joint, a fillet, the normal 5 ones, right? Still 5 no matter what you do. But that's under normal conditions. Say I've got a T, K, or a Y, or a lateral. So it comes in, particularly on a crane. You have these large 4 main structures going up and down. But instead of pieces going just straight across, they're coming out at different angles to help support each other, right? And most of you have seen a lattice crane, or you went around and seen a power line that has crisscross members within it. Usually those are what we refer to as a TK or a Y position. So T as a saddle T, right? A K, which could be this, but with 2 pieces coming out of it, one going this way and one going that way, or a Y, just at a straight 45-degree angle like that. Okay, or a lateral. Those 3 positions are usually ones that have to be done in a mock-up type situation. Now, let me clarify real quick. A T, K, and Y situation within most specifications is covered by a 6GR with a restricting ring. Okay? So if you want to qualify to a TK or a Y within the normal ranges, I think they give you like an angle of like 45 or 30 degrees. And then your K is a 30 and a 30. There are a few pre-qualifieds there, but in order to test to those, you would need to weld in not just a 6G position, but a 6GR with a restriction ring, because there's crevices that are hard to get in to weld all the way along that, right? So those are usually the ones that we use for that, unless code specifies different. But some of those other ones, the mock-up testing, if it's a piece of tubing that we need, a square tubing that we need to do for structural steel, we're going to do a mock. We're going to do exactly what we said earlier, a procedure, and then there's certain places you cut, pull the strips out of, and go from there. And I want you to look, when we talk about that, you're going to want to look at the different areas. Pages 5-19, it starts to talk about them and ask me restrictions. Page 520, 521, 522, talk about them. And then page 523 are test specimens required and thicknesses qualified for ASME. These are hard to explain on a video. I want you to look at them and then come ask me some questions. And we'll go from there, okay? All right, we'll move on to page 5. Well, let's look through the PowerPoint real quick, see where we're at. D11, D15, particularly there. We can start getting to the differences between essential welding variables. And these are the variables that have changed, you have to re-qualify, okay? They need a new procedure qualification. So that's what I was saying earlier. Say it's within, the procedure's only good for 8th inch 7018 at 120 amps. But you want to jump up to 532 electrode and we want to run 165 amps. That's an essential variable, okay? The base metal changes, the filler metal changes, even the size of the filler metal changes above it. Usually D11 tells you it can go below because there's less heat input, right? But if you go to a larger electrode, all of a sudden you're putting in more heat input, more amperage, more voltage, and usually going a lot slower. So there's a lot more heat input, which changes the grain structure and everything else, and the distortion within that part. So now, it falls under the essential variables, we have to change it, okay? It's important for us to change it at this point. We talked quite a bit about testing. You know, it can be done in almost anything and everything, welding, brazing, both, copper, steel, aluminum, stainless, everything. The ASME qualifications fall underneath section 9. The welding WPS basically lists your essential variables, so what we talked about is 718, 8 inch, and again, broken record there, okay? I'm moving on. PQR is the next one. It's actually, we actually tested it at that point. And then we talked about the difference between specimens. So read through these and they'll make sense as soon as you do. I think we covered it pretty decent. If not, come talk to me and we'll ask some questions and make sure we're all on the right path. Okay? Mock-ups, we talked about this. So here's the steps, one of two. You know, these are things that I covered in the first section. But go back, read through them, make sure that you write them down at this point and put them in your notes, as well as your essential variables and how that stuff can change. And then we talked about welder qualification. And so now we get into the variables, right? So here's the essential variables. These are things that you want to write down. What's the position? Naturally, 3 and 4 are harder than 1 and 2, correct? What's the weld joint configuration? Electric type size, backing, whether there is backing, whether there's not backing, because that depends on your skill level. It's a lot easier to put one in with a backing strip than an open rut. Type and positions. Now that's where we start getting into page 5-23. It starts talking about type and number of specimens, but also on page 525, really starts talking about whether it's plate or tubular, what do we do, how do we go from there. Come talk to me and let's make sure we're all on the right path before we move forward, okay? And hopefully, you know, in the future I'm going to get a couple other devices in here where I can pull some stuff up, start circling some stuff around and things like that. Maybe make an amendment to this video as well. Thickness range qualified, so this again depends on the code used and what they qualify for. We know the difference between backing and non-backing. Fill weld test specimen, here's one. Actually, you weld from the outside in to the center, here to the center. You break it, but before you break it, you're actually going to cut 1 inch off of each end. You're going to macro etch that to see and make sure that the weld profile is good, and then you're going to fill break it to make sure you broke down the root. Okay? 6GR, so here's that restricted ring. So this is what you use if you're going to do a TK Y direction, and it qualifies you for everything underneath of that as well. Okay? If you notice, it's a single bevel pipe with the restrictor ring on the top side. Okay? There's the AWS F1, 2, 3, and 4 numbers, so I'm going to be honest with you, this has very little to do with almost all codes and documentation. Most everything else is even with AWS doesn't even accept this, because 6010 and 6011, even though they're under F3, they're still a different electrode and they're on different scales. So just try not to think too much of the F1 through 4, but think of each different electrode and each base group of electrodes. You need to go and check those out on AWS 5.1. Will give you a metal grouping or electrode grouping type. Okay? Know your specifications. So, moving on to page 5-27, we're going to talk about our weld joints. And the throat of the weld is vertical, horizontal. Most of you have talked about this or with me by this point, whether it's a 1F, 2F, 3F, 4, 1, 2, 3, 4G, groove weld, or anything like that. Okay. Page 5-27, right-hand column talks about the TK and Y. Helps explain that better. 528, 529, you can look at your different field welds or socket welds. 5-30, read both those paragraphs there. They talk quite a bit about the electrodes in group 4, considered to be the more difficult types. I know that I just told you don't worry about it, but it's good to read through this and kind of understand. At the top it tells you what's the type of specimens, what's the number of specimens. Look through that table, see if it makes sense. If not, come talk to me and I'll help you understand it as we're going through it, okay? Page 5-31, left-hand column, second paragraph down. It starts out, it says the finished test coupon is then marked to identify according to the welder's name, test position, top of the coupon in case of a pipe welded in 5, 6, and 6GR positions. So most of you have been through this with me. There's not much situation there or not much different. But the documentation at this point and the reference is very important. Move over to the right-hand column of that page. Second paragraph, the first paragraph actually down, starts out, virtually all welder qualification test specimens are generally categorized as soundness tests, including bend test, nick break test, and fillet break test. The bottom of that paragraph, 3 sentences up, says for pipe coupons welded in the 5 and 6G position, specimens are removed in relation to the top of the pipe during actual welding. That's what I mean by the, you need to make sure that you're on the top section, moving around. 533, a couple things I want to talk about. Page 5-33, left-hand column. At this point, it's appropriate to differentiate between the terms of qualify and certify, as opposed to those welder tests. If we say a welder is qualified, we mean that he or she has demonstrated sufficient skill to perform a certain weld. Certification, however, applies to the documents which support this qualification. So, and even though like I could give you a sheet that tells you that you passed all this and it's a CWI, I've done it, somebody still has to accept that, right? So the company has to say, I'm going to use this pre-qualified one as a certification. All right? And that's important to know as well. The company has to accept it and sign off on it as a company rep, not just me as a CWI. Right-hand column talks about, it says, once qualified, the welder will be permitted to weld in production as long as that welding does not involve position, thickness, electrodes, etc., which are outside the limits of the qualification. So it's kind of like the essential variables, right? As long as the essential variables are the same, then we're good to go. So say you work at one company and you do these 5 welds for a long time, or you mainly only do 5 welds, same electrodes, same positions. You qualify within them, and what AWS is saying here is they accept it to be you're qualified for as long as you go, unless you start proving. If you get to the next page, it talks about 2 pages away, I guess, 3, whatever. Unless unsatisfactory performance is suspected, okay? So if you start seeing bad welds, then it's going to be a little bit different. But I really want to sit back and I want you folks to come in and talk to me. I want you to read through these welder qualifications, this QW484 on this section here. And we're going to talk about electrode classification versus specification and so forth, okay? Quite a bit of stuff in here, okay? And if we can, I'll show you a few examples of some completed qualifications and so forth. All right, there's a lot of questions to come out of here, for sure. Make sure to come ask some questions, and we'll sit down and talk about them. Maybe get some different ones. Start researching them as well. Again, you've got an internet. There's a lot of really good stuff out there about some of these. Maybe help explain it as well. Okay? This is kind of back at the beginning. It is the fabricator's or contractor's responsibility, so forth. All right, folks. Thank you. Have a good evening.